Welcome to the first derivative test. With this, we're going to use the first derivative to give us information about either our function or, in this case, our position formula using our first derivative. Okay? So here, I'm going to start out by taking the derivative of my function. So I'm going to take the derivative and I'm going to get 3x squared minus 12x plus 9. And what I'm going to do is I'm going to find those critical points by setting my derivative equal to 0. And I'm going to start factoring. All right, so I'm going to factor this to x minus 3 and x minus 1. So that's telling me I have critical points at 3 and 1. So doing the first derivative test, I'm going to set my critical points on a timeline, or a number line here, and now I'm going to test the intervals around that critical point. So here, I'm going to plug in 0. 0 minus 3, that's negative. 0 minus 1 is negative. Negative times a negative is positive. Okay, then I'm going to test a number between 1 and 3, so I'm going to plug in 2. 2 minus 3 is negative. 2 minus 1 is positive. Negative times a positive is negative. And then I'm going to plug in a number greater than 3, which is 4. 4 minus 3 is positive. 4 minus 1 is positive. Positive times a positive is positive. So now I'm going to interpret this first derivative test. What is this giving me? Well, I now know where my function is increasing. It's going to increase from negative infinity to 1, and it's going to increase from 3 to infinity. That's where my function is increasing because the derivative is positive. My function is decreasing when my derivative is negative, so we're going to decrease from 1 to 3. And because of this changing from increase to decrease to a decrease, that's telling me I have a max at x equals 1. And here, decrease to an increase, I have a minimum at x equals 3. Okay? So we identify our critical points, put them on our number line, and test the intervals. And then we use that to interpret information about our function. Okay, over here we have a position formula. That's why it says S equals. It's a position. So when we take the first derivative, we're looking at velocity. That's going to give us a little bit more information about what is happening. So if I take the derivative and I get my velocity formula, 3t squared minus 18t plus 15. Again, I'm going to set this equal to 0 to find those critical values. And I'm going to get the factors t minus 5 and t minus 1. So my critical points here are 5 and 1. Set them up on a number line, 1 and 5. And then again, I'm going to test around those points. So if something's less than 1, I'm going to plug in 0. That's going to be negative times a negative. So that's positive, plugged in 0. Between 1 and 5, I'll just go ahead and plug in 3. That's going to give me a negative times a positive. So that's negative. And I'll plug in 6. That's going to be a positive times a positive. So it's positive. Okay, so if this is a position formula. That position is changing. When is my particle moving to the left? Well, that's when my velocity is negative. So we're going to move to the left from 1 to 5. We're moving to the right from 0 to 1, and then 5 to infinity. And when does it change directions? It can only change directions at the zeros. So it's changing at t equals 1 and t equals 5. Okay? So again, we identify the critical points. Use the first derivative test, which means we're plugging these values into the first derivative,
and then interpreting our findings. Good luck!